Hello everyone, I'm Paul and today we're solving problem 3408, Design Task Manager. This is medium, so next I will show you my intuition, approach, and efficient solution. We need to implement the Task Manager class here. For this, first we need to create some data structures and then we need to implement 4 methods: add, edit, remove, and exec top. And this might seem tricky, there's a lot going on here. But actually, we need 2 data structures to solve this: a sorted list and a map. This is all we need to solve this problem. So let's start here. We need to execute the task with the highest priority across all users. So what information do we need to put inside this sort list? Well, we are including the priority for sure, because we need to execute the task with the highest priority, and we know that we need to sort this by priority, so this will be the first element in each tuple. We know that we also need the task ID in case there are multiple tasks with the same highest priority. We need to execute the one with the highest task ID, so that's why we are also including this here. And we also need to include the corresponding user ID because the return value for this method is the user ID. So these are the 3 values that we are including in every tuple. So if we are given these tasks, for example, we know that the format for this is user ID, task ID, and priority. And we need to store each of these with this format in this short list. First, we are here, so we add a priority of 2, the task ID is 1, and the user ID is 1. So now we are here and we need to add a tuple with the current priority 1, the task ID 2, and the user ID is 1. Now the question is, how should we sort this? How should we sort this sort list? And remember, first we need to sort this by priority, meaning by the first element in ascending order. And then we need to sort this by task ID, meaning the second element in ascending order. And this is the way sort lists work. First, we sort tuples by the first element, and then we sort tuples by the second element. And this is fine. So we are keeping the default order for sort list. We are sorting this entire thing in ascending order. And when we call this method exec top, we are removing the last tuple in our sort list. Now, given that we are sorting this in ascending order, we need to swap these 2 elements. So when we add this task, we add this tuple here in the first position, and when we run this function, this method, we pop this last element and we return the last element in the tuple, which corresponds to the user ID. So when we call add, we can just add the new task here. Now the question is, why do we want a map? And this is because of these 2 methods. We have one method in sort list which is discard, and with this we can remove tuples. So let's say we want to remove this tuple, but we don't want to iterate through this entire sort list. So we can use discard to remove this in log n complexity. But if we want to select this tuple, we need to build this entire key. And here in edit, for example, we are given a task ID and a new priority. So we need to find a way to get this value efficiently. And that's why we have a map here. Here we are storing the information for tasks. So first, when we are here, we are iterating this and we are at this task. We are adding to this map the current task. Remember, task ID is the element in the middle. We are adding 1 as a key. And the value for this is the tuple with the priority for this task, meaning 2, and the user, which is 1. Next, when we are here, we add task number 2. So now let's say we want to edit task number 2 and the new priority is 5. The first step is we go to the map, add task ID, meaning we are here, and now we can build our key to remove the corresponding tuple from our sort list. Our key has to follow this format. First we have priority, then task ID, and then user. We have the old priority, it's 1. The task ID, we know it's 2. And the user is this 1. So now we are looking if we have this key in the sort list, and we have it right here. So we can remove this, and now we can add a new tuple with the new priority, which is 5. And here we are adding task ID, which is 2, and the user, which is 1. So we are adding this tuple up here. And now we can update this. We know that the new priority is 5 and the user is still 1. And if we want to remove a task, the process is very similar. We are given a task ID, let's say this is number 2, and we can go to our map, add task ID, and with this we can build the corresponding key to remove the corresponding tuple from here. So the first element in the tuple is the priority 5, the second element is the task 2, and the third element is the user 1. And now we're checking if we have this key up here, and we have it right here, so we can remove this, and after removing this we can remove this from the map also. And now we only have one tuple here, so let's say for example we run this method and we go to the last tuple in our sort list, meaning this one. This is the only tuple actually, and we return the value corresponding to the user, meaning number 1, and we remove this from sort list. And we can remove this task from the map just to keep this clean. So this is it. This is basically the entire approach. Now with this in mind, let's go with the code. So we need 2 data structures, a sort list and a map. So self.sl, this is sort list, and self.taskinfo, this is an empty map. And now we can iterate tasks. So for every user, task, and priority in tasks, self.sl.add, we add a tuple with the following format: priority, task, user. And self.taskinfo at the current task is a tuple with priority and user. And now for this method, self.sl.add, this is very similar. We add priority, this is this priority. We need to add this task ID and this user ID. So we add a tuple with priority, task ID, user ID, and self.taskinfo, task ID. This is a tuple with priority and user ID. Now for this method, this is more tricky. Here we need to use self.taskinfo with the corresponding task ID, and this will give us the old priority and the corresponding user. And with this information, we can build our key to destroy the corresponding tuple in our sort list. So self.sl.discard, and our key is all priority, task ID, and user. And now we can add the new tuple. So self.sl.add a tuple with new priority, task ID, and user, and self.taskinfo at task ID. This is our map. Here we need to replace the current tuple with a new tuple with new priority and user. For remove, we can do something very similar. All priority and user. This is self.taskinfo at task ID, and self.sl.discard. Here we are discarding the tuple corresponding to our key. So all priority, task ID, and user. And now we can remove from self.taskinfo task ID. And now for this, first, if we don't have a sort list, we need to return -1. This is in the problem description. So if not self.sl, we just return -1. Else, we take the last element in sort list, so all priority, all task, and user. This is self.sl at -1. And now self.sl.pop, we remove the last element, and the problem says that we need to return the corresponding user. So this is it for the code. Now let's submit this and see if it works. I'm missing an S here, so let's fix this and try again. As you can see, this works and it's efficient. Time complexity for this part will be big O of n times log n. Remember that operations in sort list require log n time complexity. So this is overall big O of log n, this is log n, this is log n, and this is also log n. And space complexity is big O of n. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.